Okay, today is Wednesday, March 17th, St. Patrick's Day. We're on a fog day today. And we finished number 28 in class. So I just want to recap. Remember your percent yield's experimental divided by theoretical. When you do this stoichiometry stuff, you're figuring out the theoretical. Your experimental is what shows up on the pan, or the balance pan. And we're going to do a lab where we do this coming up. So we finished this when you were turning 14 grams into a grams aluminum chloride. So in your mass to moles to moles to mass diagram, we were doing the whole thing on this one. On to number 29. Page 387. Zinc reacts with iodine in a synthesis reaction. I showed you this reaction earlier in the year, I'm pretty sure. It makes a real mess. We did it in the fume hood. Zn plus I2 gives you Zn(I2). Determine the theoretical yield and then the percent yield. Okay? So, we have in the problem 1.912 moles of zinc used. So draw your equation. Zn plus I2 gives you Zn(I2). That's already balanced because I have 1 times 1 zinc, 1 times 1 zinc, 1 times 2 iodine, 1 times 2 iodine. This reaction does, however, give you a lot of heat when you do it. And you've seen it makes a mess inside the Erlenmeyer flask. So since we are going from moles to we want to know how many grams, we are doing moles to grams. Mole A is played by, the role of A is played by zinc. The role of B is played by zinc iodide. What we were after is grams zinc equals X grams zinc. X equals so many grams zinc. Okay, this is going to be our theoretical yield. Theoretical yield. Zinc iodide, actually, zinc iodide, Zn(I2). Okay. Theoretical yield. All right, so if I start with this over 1.912 moles of zinc over 1, then I've got to change to moles, so that's going to be a set of parentheses, and then I got to change to mass, that's going to be a set of parentheses. So I'm going from moles zinc to moles on top, Zn(I2), and then on the next one, the next arrow, I've got another one of these. I'm going from moles of zinc to grams, Zn(I2). And this goes here. Moles zinc, so that it cancels. And then this goes here, and it will cancel. Whoops. Moles Zn(I2). Okay. So that will cancel. You get, in the first step, the numbers from the balanced chemical equation. And those are 1, 1, and 1. So 1 mole of zinc, 1 mole of Zn(I2). And the other numbers come from the periodic table. So I'm going to do those in purple, or whatever color this is. So I have 2 iodines. Iodine from the periodic table, I think, is 127. Yep, almost 127. So I have a 127 times 2. And I think zinc's 65 point something. Zinc is 65.4 was a little short of that, so we'll go 65.3. Okay, about 319 grams per 1 mole. This is a 1. We'll go to 319. Now, I feel like I made a mistake there, so let me check. I didn't. Nope, it's 319.2. Okay, I didn't do my rounding right, so I'll go ahead and do that. 319.2 is 1 mole of zinc iodide. Now remember, zinc is in the transition metals, but you don't say zinc 2 iodide because zinc is always 2 positive. We talked about why earlier in the year. So you multiply all this out, and it comes out to be, I can do that right here, 1.912 equals 611 grams. Almost. 611 grams. Now that is my theoretical yield. So if I look at the next section, determine the percent yield if 515.6 is recovered. So my percent yield is equal to my experimental, or what the book calls actual, divided by the theoretical, times 100. And we have an actual yield recovered, or an experimental yield of 515.6 grams, and we're supposed to get about 611 grams and change. I don't have the, and multiply that times 100, and you don't want to push the percent key on your, it's really 100%, but we'll soon see that they push the 100% key on the calculator, and then it changes that to 1, and it doesn't change this. So I'm going to leave the percent sign off. And anyway, it comes out to be, looks like 84.5%. I'm going to delete this other page because it's messy. Okay, let's go on to number 30. When copper wire is placed into silver nitrate solution, silver crystals and copper 2 nitrate solution form. Write a balanced chemical equation for the reaction. Okay, I put my subscripts in here even though you really could get by without them. You don't have to pay much attention to this. What kind of reaction is this? Well, it's not synthesis because I have more than one product. A plus sign. It's not decomposition because I've got a plus sign there. It's not even redox. Well, yeah, it is redox, but anything can be redox. Well, that's 0 oxidation number. That's 2 positive, so right away, we know that's redox. It's not double replacement because that doesn't have a partner. Here it does. It is single replacement, because the positive ions switch places, silver and copper switch places, the metal atoms switch places. It's not combustion, so it's single replacement. Now we need to balance this. Silver nitrate's AgNO3, copper 2 nitrate has to have 2 nitrates. Do they tell you this? There's different ways to do it. Okay, they tell you it's CuNO3 too, okay? And they told you this, which means I need 2 nitrates, which means I have to have a 2 there. And if I have 2 nitrates, I have 2 silver, so I have to have a 2 here. And we want to know, if we start with 20 grams of this, how many grams of silver do we end up with? So let's determine a theoretical yield. So we are looking for, make sure you know what you're looking for, so you're not going to find it. We are looking for X grams silver, X equals so many grams silver. And we are turning grams into grams. So we'll say question mark grams. So we are doing this whole thing, mass in grams to moles to grams again. Now let's put what we do know. We have 20.0 grams of copper. Over 1. And we want to go grams. Copper's playing the role of A. Silver's playing the role of B. So we're going grams of A, mass of copper, to moles of copper. And then next is moles B. So we are going to moles Ag, silver. And then the last step is to convert to grams of silver. Okay? Just trying to make this a little neater. Okay. So mass to moles to moles to mass, mass to moles to moles to mass. AA, BB, AA, BB. This goes here, this goes here, this goes here. So grams CU, moles CU, moles AG, okay, now we can go ahead and cancel things out. Grams copper, cancel grams copper. Moles copper, cancel moles copper. Moles silver, cancel moles silver, and we're left with grams silver, so we can be very confident, as long as we get our numbers in here right, it's going to be correct. All right, from the first one. Okay, we get our numbers from the periodic table. So from the periodic table, a mole of copper is 65.5 grams, I think. 63.5. Yeah, 63.5 roughly. 63.5. The next step comes from the balanced chemical equation. 1 copper gives us 2 silver. So 1 copper is 2 silver. And then from the last step, we get the numbers from the periodic table. And from the periodic table, 1 mole of silver, it's 107.9, I think. Check that out. Yeah, I think so. 107.9. Multiply the tops, you're going to get 40 times 108, so it's going to be something 48, 4,048 or something like that, divided by 63.5. When you do that, 20 times 2 is 40, times 107.9, a little less than 4,048 maybe. Must be a little less than 4,800. 4,312 divided by 63.5, because that's 1 times 1 times 1 times 63.5, is 67.9 grams of silver. Now, something I didn't tell you is when you do a math problem like this, look at it and see if it makes sense. See if your numbers are in the ballpark or way out in left field. If you have 20 grams of this, and I get 2 silvers for that, automatically that would be 40. And then silver is quite a bit heavier than copper, so less than 70 sounds ballparkish. I mean, this doesn't say 75,000 or 0.00032. So see if you're kind of in the ballpark. All right, now we want, on the next part, if 60 grams is recovered, determine the percent yield. So I'm going to go back over here if I can, because I know I had a nice, there we go. Edit copy. Edit paste. Let's put that one there. So that's the equation we're going to use. And so our percent yield, our theoretical we just found, so that's 67.9 grams silver. And I think it said 60.0 grams silver. Grams silver is going to cancel times 100. And it should come out to be 88.2%. Doing that. I'm going to go back and delete this page. Okay, next. See how much time we got. We'll stop there and do the last two on another one.